This is the Math 3 Unit 10 Worksheet 4. I'm going over a couple of the homework problems. So number 1 through 10 say to identify all the possible quadrants in which the terminating ray for theta could lie. So here on number 1 we're told that cosine of theta is greater than 0. So we're going to have to remember that in the unit circle, okay, unit circle is a circle with 0, 0 as the center and a radius equal to 1. That the cosine of theta is your x-coordinate, the sine of theta is your y-coordinate, and the tangent of theta is your y over x coordinate, or we could say sine over cosine. And so that's going to help us out with 1 through 10. Because when it says cosine of theta is greater than 0, that's telling us the x value is greater than 0, which means x is positive. So what quadrants is x positive? Well, x is positive on the right side of your graph, right? In quadrant 1 and quadrant 4. So 1 and 4 are the two quadrants in which cosine of theta is positive. Number 3, tangent of theta is positive, so that's telling us that y over x is positive. So we got two cases. Case 1, both x and y are positive. In case 2, both x and y are negative. So if x and y are positive, we're in quadrant 1. If x and y are negative, we're in quadrant 3. Take a look at number 7. Cosine squared is greater than 0. So that's saying that x squared is greater than 0. Well, if you square any number, you're going to get a positive answer. And so what does this tell you about x? Well, x is positive would work, right? Or x is negative would work, because if x is negative and you square it, it's still going to be positive. And so x could be positive or negative. So it doesn't matter which quadrant we're in, it's going to be true in all 4 quadrants. Quadrant 1, 2, 3, and 4. Number 9, we have that the tangent squared is less than 0. Tangent is y over x, and when we square that value, we're going to get something negative. So hopefully you recognize that there's something wrong with this, because when you square a number, as long as the number is real, and all the values on the unit circle are real, if you square a number, you should get a positive answer. And here we're getting a negative answer, and so this is impossible. There's no solution. Because when you square a number, you need to get a positive answer. 11 through 21 were to solve for all the values of theta, such that theta is between 0 and 360. Hint, have the special right triangles handy and keep in mind the quadrants where sine, cosine, tangent are positive versus negative. So we have the 30, 45, and the 60 drawn here. If we want for 30, I'm going to use lengths 1, 2, and root 3. 45, I'm going to use lengths 1, 1, and root 2. And 60, I'm going to use, again, the 1, 2, and root 3, which is the same triangle as the first, just oriented differently. They remind us that, okay, sine is our y value, right? And so our y y values are positive above the x-axis, negative below. Cosine is your x value. So x values are positive on the right side of the y-axis and negative on the left side. And tangent is y divided by x. And if both x and y are positive, or both are negative, then we get tangents positive. That's what we see quadrant 1 and quadrant 3. If one is positive, one is negative, then the tangent will be negative and we'll end up in quadrant 2 or 4. So with that in mind, let's try number 11. What we're going to do first is solve for the sine of theta. So here we get, I'm going to add 1 to both sides, and I get sine of theta is equal to 1, and then divide by 2. So sine of theta is 1/2. So we know that the sine of 30 degrees is 1/2. Just look at the triangle above, where 1 is the opposite side, 2 is the hypotenuse, sine is opposite over hypotenuse. But is that the only one that will satisfy this? Well, if the sine is positive, okay, that's telling us that our y value is positive. Okay, and so our y value is positive, or the sine is positive in quadrant 1 and in quadrant 2. So I'm going to draw a reference angle with 30 degrees in quadrant 1 and a reference angle of 30 degrees in quadrant 2. And we're wondering, where are these terminal sides pointed? This is 0, 90, 180. So if we're in quadrant 1, we're pointed at 30 degrees. If we're in quadrant 2, we're pointed at 30 degrees less than 180, which is 150 degrees. And so those are our two answers. The sine of 150 will give us 1/2, and the sine of 30 will give us 1/2. So theta is either 30 or 150. You need to give both answers. Number 13, we're going to solve for tangent theta first by subtracting 5 and then dividing by 5. And we end up with tangent theta equals 1. Well, the tangent of 45 is 1 over 1, which is 1. So 45 is our reference angle. So now we need to ask ourselves, this is tangent of theta is negative 1, and we know the tangent of 45 is a positive 1. Which quadrant is tangent negative? And tangent's negative in quadrant 2. So I'm going to draw a 45 degree reference angle in quadrant 2, and tangent's negative in quadrant 4. So I'm going to draw a 45 degree reference angle in quadrant 4. And we're curious, where are these terminal sides, the hypotenuse, pointed at which angle? So this is, we have 0, 90, 180, 270, and we're looking between 0 and 360 only. And so in quadrant 2, it's 45 past, well, it's 45 less than 180, which is 135 degrees. And in quadrant 4, it's 45 less than 360, which is going to be 315 degrees. So those are our two answers. So theta could be 135 degrees or 315 degrees. We don't want to say tangent's 45 because that's positive 1, and in our case we have tangent theta equals negative 1. So the tangent of 135 or the tangent of 315 both give you negative 1 as an answer. Number 15. Solve for cosine squared. We end up with 2 cosine squared theta equals 1. Divide by 2, cosine squared theta is positive 1/2. Then we take the square root of both sides. When you take the square root of the left side, we end up with the absolute value of cosine theta. Is equal to the square root of 1/2 which is the square root of 1 over the square root of 2, which is 1 over square root of 2. And if I multiply top and bottom by root 2, I end up with root 2 over 2. Now because we have the absolute value, to get rid of that absolute value, we can say that the cosine of theta is either positive root 2 over 2 or negative root 2 over 2. So we can say plus or minus root 2 over 2. So which angle are we talking about here? Cosine of what angle is root 2 over 2? Well, if we look at the 45, we're going to get the cosine of 45 is 1 over root 2, which is what we have at that location. So we know that the cosine of 45 is root 2 over 2, which just tells us that 45 is our reference angle. Also, we need to notice that the cosine is positive or negative. Well, cosine is our x value, and it's positive or negative in all 4 quadrants. So we're going to have 4 different answers here. So draw a reference angle of 45 degrees in each of your 4 quadrants. And we're interested in where these terminal sides are pointed. So 0, 90, 180, and 270 I'm putting on to just give us a point of reference here. And so in quadrant 1 we're pointed at 45 degrees. In quadrant 2 it's 45 less than 180, which is 135 degrees. In quadrant 3 it's 45 more than 180, which is 225 degrees. And in quadrant 3 it's 315 degrees. So theta is all 4. 45, 135, 225, and 315. Let's take a look at number 21. 21 we need to first distribute. So tangent theta times tangent theta is tangent squared theta. Tangent theta times negative 1 is negative tangent theta. Root 3 times tangent theta is positive root 3 tangent theta. Actually, I am sorry. I am going about this wrong. It's already factored for us. So we do not need to distribute that. That is causing more of a pain here. If it's already factored for us, we're going to use the zero product property. And we're going to write that tangent theta plus root 3 could be equal to 0, or tangent theta minus 1 could be equal to 0. In the first case, we get tangent theta is equal to negative root 3. In the second case, we get tangent theta is equal to positive 1. And so we need to see, we have two separate problems here to solve, and each one's going to give a different reference angle. We talked about already in number 13 that the tangent of 45 is 1. Okay, so I'm going to use that. But the tangent of what is going to be negative root 3? And so let's go back to our triangles up here. If I talk about the tangent of 30, I end up with opposite over adjacent, so 1 over root 3. If I look at the tangent of 60, I get root 3 over 1. And so we see the tangent of 60 is equal to root 3, not the tangent of 30, not the tangent of 45. And so tangent 60 is root 3. But this is negative, and so we want to work in quadrants. So 60 is our reference angle, and we want to work in quadrants 2 and 4, because that's where tangent's negative. On the right hand side, 45 is our reference angle, and we want to work in quadrant 1 and 3, because that's where tangent is positive. So in quadrant 1 and 3, I'm going to draw a 45 degree reference angle. In quadrant 2 and 4, I'm going to draw a 60 degree reference angle. And we're interested in where these terminal sides are pointed. All four of them. We have 4 different answers. So this is 0, 90, 180, and 270, and back to 360. So in quadrant 1, we're pointed at 45 degrees. In quadrant 2, we're 180 minus 60, which is 120 degrees. In quadrant 3, we're 180 plus 45, which is 225 degrees. And in quadrant 4, we're 360 minus 60, so at 300 degrees. And so our answer is theta is 45, 120, 225, and 300 degrees. (22) at least give you a hint, get you started on this one. It says if tangent A is 3/4, then find the perimeter and the area for the isosceles triangle ABC. So if I drop an altitude from B, so an altitude goes through the vertex and is perpendicular to the base, okay, we get 2 right triangles, and we know it's an isosceles triangle, so we know that angle A and angle C are congruent to each other. And so here now we could say that triangle AB, let's call this point D, is congruent to triangle CBD by angle side. Okay, so then we can get that AD is congruent to CD because corresponding parts of congruent triangles are congruent. And this reasoning is important because now we know that AD is 20. This is split up to 20 and 20. Not always when you drop an altitude does it split the bottom half and half, but in this case it does, and it does with all isosceles triangles because of this. So we had to do this first to create a right triangle because we're working with tangent, and tangent applies to right triangles. It's a ratio of the opposite over the adjacent. And so here, let's let our opposite side, which is the height of the triangle, we'll call that h. And we know that the tangent of A is equal to 3 over 4. But from our picture, we know that the tangent of A is equal to h over 20. And so this gives us a proportion in which we can cross multiply and get 4 times the height is 3 times 20. So 3 times 20 is 60. So 4 times the height is equal to 60. And then divide, you end up with 15. So now the height's 15. And we're after the perimeter. Now the perimeter is the length all the way around the triangle. We know the bottom length is 40. We know AB is congruent to BC, so they're the same length. We just need to find out what AB and BC is. And so we're not done. Why don't you finish?